We will start within 1 or 2 minutes. Okay, so yesterday I have given one numerical for you, okay, to solve at home. Have you done that? All of you have solved it? Yes, no. Do my voice is audible to all? Okay, so I have given you the sum part of the numerical. We have seen the problem when the motion of the block up the plane. Then one more thing is that we have to calculate the force when the block is moving down the plane, sliding down. The motion is downward side, sliding down. So have you solved that? Yes. Which I have given you as a homework. I think in the last lecture I have given that. बोला लवकर लवकर. Anybody have solved that? You can give me the answer of that if you have solved. सोडवले का कुणी?
P is equal to 48.62 Newton.
48.62. Let me check. P is equal to no 48.62. Okay, correct. Okay, so those who have not solved that example, I am again telling you, please solve it. It is good for your practice. So now the next is the ladder friction. Next is ladder friction. Okay. First of all, we will write some description, and then with the diagram, I will explain you how the ladder friction occurs. Okay. Now, right here, consider, you also write with me, consider a ladder rest at A and B. Okay, full stop. A man having weight W, man having weight W is at point C. Is at point C. Okay. Full stop. Due to load W, load W if the ladder slides then direction of frictional force direction of frictional force and normal reaction are shown in the figure. Okay, so basically what we have said, that consider a ladder. So ladder is there which is at rest at point A and B. कुठल्या तरी भिंतीला लावून उभं केलेली आहे ladder. Okay, so let us say that the point which is at ground floor, that is A, and the point which is resting at wall, it is B. A man is having weight W is at point C. म्हणजे त्याच्यावरती कुठला तरी माणूस चढलेला आहे त्या शिडीवरती आणि त्याचं वेट काय W. Okay, due to the load W, if the ladder slides, okay, so due to the load, if the ladder slips or slides, then the direction of the frictional force and the normal reactions are shown in the figure. So now we will draw the figure. Okay, suppose now this is wall, and then this is the floor. Now I will draw the ladder. Let us say that this is the ladder. Okay, this is the ladder which I have drawn over here. Now say this is point A, this is point A, this is point B, and now at point C, at this point, let us say that this is point C. Now on this point C, who is there? A man is there whose weight is W Newton. Okay, so if I show that, so here at this point C, one man is there and his weight is W Newton. So the weight of man is W Newton. Okay, so in addition to this, this ladder is having its own weight. Okay, एखादा माणूस त्या शिडीवरती उभारलाय, ठीक आहे, त्या माणसाचं वेट असणार आहे vertically downward. But in addition to that, the ladder is having its own self weight. So that self weight will be act through the CG of the ladder. Okay, that self weight will act through the CG of the ladder, and suppose that point is this one. And now from here, I will show the self weight of the ladder. This is the self weight. This is the self weight of the ladder. Let us say it is small w. Okay, so capital W is the weight of man, and small w is the weight of ladder, self weight of ladder. Now see, this ladder is like this. Okay, भिंतीवरती अशी आणि इथं अशी. Okay, ladder हे असं आहे. आणि इकडे वॉल आहे, अशी इथं वॉल आहे आणि इथं फ्लोर आहे, अशी लॅडर आहे. आता ह्याच्यावरती इथं एखादा हे उभारलेला आहे माणूस, तरी पडल कशी? ज्या वेळेला लॅडर स्लिप होईल, हाऊ इट विल स्लिप? वेन द लॅडर स्लिप, तुम्ही कधी शिडीवरनं पडलाय का? बघा इमॅजिन करून कसं पडलं. त्यावेळेला शिडीची मोशन काय झाली? लेट दिस अँगल इज थिटा. ओके, दिस अँगल इज थिटा, इट इज इन्क्लाइन एट एन अँगल ऑफ थिटा. ओके, सो व्हॉट विल हॅपन? इमॅजिन करा की तुम्ही शिडीवरती चढलायत आणि तुम्ही शिडी स्लिप झाल्यामुळे पडला, तर ती कसं पडेल? हाऊ यू विल फॉल डाऊन? व्हॉट विल हॅपन ऍक्च्युअली? दिस पॉइंट बी विच इज ओरिजिनली हिअर ऍट दिस वॉल, दिस विल कम डाऊन, and this point A which is over here, this will move to this side, and then this ladder will slip. Okay, ladder will slip. म्हणजे कसं होणार आहे की initially this is the ladder. So this is your point A and this is your point B, and here some person is standing at this point. Okay, when it slips, then after slipping its position will be like this. Okay, its position will be like this. It will slip like this. So This is your A and B. So from this wall and from this floor, okay, it will come down. So the motion of this B point is in this direction, and the motion of A point is in this direction. This is the concept which you need to understand. Have you understood this? बी पॉइंट कुठे जाणार आहे? खाली डाऊनवर्ड जाईल. जेव्हा तुम्ही शिडीवरनं पडताल, शिडी कशी पडेल? जो वॉल कडचा पॉइंट आहे शिडीचा, जी तुम्ही अशी इन्क्लाइन शिडी ठेवलेली आहे, वॉल कडचा जो पॉइंट आहे तो खाली येईल, बरोबर आहे. आणि जो खाली ऑलरेडी तुम्ही फ्लोअरवर ठेवलेला आहे तो मागे सरकेल. म्हणून आपण कधी कधी काय करतो, तुम्ही तो कोणाला तर उभं करता धर शिडी म्हणून, तुम्ही इथनं फोर्स लावायला लावता शिडीला. आपण धरतो म्हणजे काय, एखादं कोण जर शिडीवरती चढला असेल किंवा लॅडरवरती, इफ समवन इज क्लाइम्बिंग ऑन द लॅडर, वी टेल टू अदर पर्सन दॅट प्लीज व्हॉट वी कॅन से, please put your hands on the ladder so that it will not slip. So when you are keeping your hands on the ladder, indirectly what you are doing, you are applying some force in this direction. Why you are applying that force? Because this A point, when this ladder will slip, this A point will move to this direction, leftward side, okay, and this B point will move downward. Okay, is it understood?
Yes, sir.
Okay, so now we will show the frictional forces and normal reaction at both the points A and B. Okay. Now see over here. This is first of all, I will draw the direction of the motion. So if you see, the direction of motion of point B is this direction, downward, and direction of motion of point A will be this direction. These two are the directions of the motion. Once you get the direction of the motion, then rest of the things are very easy. This is the direction of the motion. Now see, at this point B, this wall is vertical. Now I have already told you, this is the surface. Okay, this is the surface. This is nothing but surface. Wall is also surface, and this floor. Okay, so now you can see here at this point B, your surface is vertical. The wall is vertical, surface is vertical. Then the reaction must be horizontal, because reaction is always perpendicular to the surface. So here your reaction will be RB. Okay, and the motion of point B while slipping, the motion of point B is in downward direction. So the frictional force here, so the frictional force, if I show you the frictional force, this is the direction of the frictional force. The direction of the frictional force, I will call this as F, and it is at point B, so it is FB. It is FB. You can write FB is equal to mu B into RB, because F is equal to mu into R. That is your ultimate formula. Okay. Similarly, when you think about point A, now here first I will draw the normal reaction. So here you can see your surface is horizontal. Your surface is horizontal. This is the floor. This is the floor. So this is the horizontal floor. So if the floor horizontal surface is there, then your reaction will be vertical. So this is the reaction. This is your reaction RA. Yeah. And now the motion, you can see motion of this point is in this direction. So your frictional force is always in the opposite direction of the motion. So the frictional force is like this. This is the frictional force. Okay. And this frictional force, I will call it as FA. This frictional force, I will call it as FA. Okay. So this is the free body diagram of a ladder. Whenever the numerical on the ladder asks, they will ask you to find anything from this. They may ask you to find out FA, FB, RA, RB, anything. Okay, or the angle theta. So this is the free body diagram of the ladder, how the ladder slips and how the forces are getting developed on the ladder. So anybody is having any doubt, you can ask me now. If you are having any doubt, you can ask me. This is the ladder. I have shown the frictional forces at the points A and B. I have shown the normal reaction at points A and B. I have also told you how the ladder slips, what is the direction of motion of point B and direction of motion of point A. So this we have studied in this 5-10 minutes. So now if anybody is having any difficulty in this, you can ask me right now. So is it understood? Shall we move forward?
Yes, sir.
Yes,
Okay. If this is understood, then we will start with the numericals on the ladder. Yeah. The first numerical, a ladder of length 4 meter, weighing 200 Newton. So the self weight of ladder is 200 Newton. A ladder of length 4 meter weighing 200 Newton is placed against the vertical wall as shown in figure. So figure is given to you. The coefficient of friction between the wall and ladder is 0.2 and that between the wall and ladder and between lower means lower surface, lower and the ladder is 0.3. Okay, full stop. In addition to self weight of the ladder, in addition to self weight of the ladder, it has to support a man of weight 600 Newton at a distance of 3 meter from lower. At a distance of 3 meter from lower. Calculate the minimum horizontal force applied at A to prevent the slipping. This is the given numerical, so I will read. A ladder of length 4 meter. So the total length of ladder is given to us. It is 4 meter. It weighing 200 Newton. So its self weight is 200 Newton. Is placed against a vertical wall as shown in figure. So I will draw the figure. The coefficient of friction between wall and ladder is 0.2. So the frictional coefficient between wall and the ladder is 0.2. It is given. And that between the surface, that is the lower surface, The floor and the ladder is 0.3. In addition to the self weight of the ladder, it has to support a man of weight 600 Newton. Okay, so in addition to self weight, there is a load of 600 Newton, which is at a distance of 3 meters from the lower, so from the surface. Okay. Calculate the minimum horizontal force applied at A to prevent the slipping. Calculate the minimum horizontal force applied at A to prevent the slipping. That is the problem. So what we will do now, we will draw the diagram first. This is the vertical wall. Then I will draw the ladder by line diagram only. This is the ladder. So on this ladder, a man of weight 600 Newton. This is the man whose weight is 600 Newton, and the weight of ladder, it will be somewhere here. It is 200 Newton. Now how I have shown this? Because this is 600 Newton and this is 200 Newton. This total length of the ladder, this total length, it is given as 4 meter. This total length, it is given as 4 meter. And this length from this point, it is 3 meter up to this person. This point is your A point. Here it is A point, and this is B point. So this distance is 3 meter, and the outer, this total distance, it is 4 meter. So the CG of the ladder, it is at a distance of 2 meter. But generally we consider ladder as a rectangle. Okay, so 2 meter, and then this angle is given to us. This angle, it is given as 60 degree. 60 degree. And now what they have told us, A point, right here, A point. So now what they have told us, calculate the minimum horizontal force applied at point A. So this is the horizontal force which is applied at point A. This is the horizontal force which is applied at point A. The value of this force is P, and that we need to calculate. What is the value of this P, so that this this will not slip. This ladder will not slip. Okay, just 1 minute. So now P we need to calculate. So again we will draw the free body diagram. So you know that when this ladder will slip, if this P force will not be there, then this ladder will slip. And how it will slip? This point B will move downward, and this point A will move to the left hand side. So here, first of all, we will draw the normal reaction at point B. So this is the normal reaction at point B. I will call this as a RB. Then the normal reaction at point A. This is the normal reaction at point A, and we will call this as RA. Then we will show the frictional force. So this point B will move downward. So the frictional force will be in this direction at point B. And here at this point A, the frictional force will be in this direction. Okay. So this is FB and this is FA, frictional force. Now we need to calculate the value of that P. Okay, we need to calculate the value of that P. Okay. So here you can use summation fx equal to 0, summation fy equal to 0, and moment at any point equal to 0 to solve the numerical. Okay, now if you observe carefully in this problem, here how many unknowns are there? How many unknowns are there? If you look at there first, then 1, 2, 3, 4, 5, you will think that there are 5 unknowns. But no, actually there are 3 unknowns. Those unknowns are RB, RA, and P. Why I am saying that FA and FB are not unknown? Because once you know the value of RB, you can calculate the value of FB. तुम्हाला coefficient of friction दिलेला आहे ना इथं. The wall and ladder, the coefficient of friction between wall and ladder is 0.2. So once you know the RB, you can use the formula mu into RB and you will get the value of FB. Here the same thing is there. Once you know the value of RA, the coefficient of friction is given as 0.3. So by using the formula mu into R, you can easily calculate the value of FA once you know the RA. So our main job is first find out RA, RB, and then we can find out this force P. Okay. So now what I will do here, first of all, I will write the relations. So FA is equal to mu A into RA. Suppose this is given. So FA, so mu A is 0.3. So it will be 0.3 into RA. So this is our equation number 1. FA is equal to 0.3 into RA. Similarly, FB is equal to mu B into RB. So between the wall it is 0.2. So it is 0.2 into RB. This is equation 2. Okay, FAB. Now what I will do, I will take the moment of all the forces about this point A. I will take the moment of all the forces about this point A. Now, if I want to take the moment of all the forces about this point A, you can see clearly this P force, it is passing through point A. So its moment will be 0. This FA, it is also along this P force. So its moment is also 0. This RA is also passing through point A. So its moment is 0. So these 3 forces will become 0. Okay. Now the moment of this 200 Newton force. So this distance we need to find out. What is the distance of this? If this angle is 60 degree and this distance is 2 meter, because this total is 4. हे टोटल किती आहे 4 आहे. 200 म्हणजे काय आहे तर सेल्फ वेट आहे कुणाचं लॅडरचं तर ते 4च्या सेंटरला येणार आहे म्हणजे हे किती असणार आहे 2 मीटर असणार आहे एवढं. So this length is 2 meter, this angle is 60 degree, you can easily find out this side. Okay, you can easily find out this side. Also 200 into this distance, then this 600, what is the distance from this point A? This total distance is from point A. So this is 3 and this is 60. Okay, so it will be 3 cos 60, you will get this distance. Okay, then again here this force RB. So to calculate the distance of RB, this is the distance of RB from this point A. You can see it is moving at this. If I extend the line of action of B, you can see this is the line of action of B. Okay, so this is the distance, this is the line of action of RB. So from point A, it is at this much of distance, and this distance is nothing but this one. Okay, now this force FB, I have shown it here, but it will be on the surface. Frictional force on any surface वर असणार आहे ना. So FB will be here. So the distance of FB from this point will be this total distance. And if this is 4, this total will be 4 cos 60. This total will be 4 cos 60. Okay, so now we will solve this. Okay, now we will solve this. We will take the moment about A equal to 0. Clockwise forces plus anti-clockwise forces minus. Okay, clockwise forces plus anti-clockwise forces minus. So now if you take the moment of all the forces at this point, these 3 will become 0. Now this 200. So what is the moment of this 200? 200 into force into perpendicular distance. So see, this force is vertical. So this will be your perpendicular distance. This is your perpendicular distance. Then this distance, this hypotenuse, it is 2 meter. This is 2 meter. This angle is 60 degree. Okay. So this will be, this length is, how much it is? It is 2 cos 60. It is 2 cos 60. So now it is, नंतर या सर लेक्चर झालं, बोला बोला लवकर बोला. So it is 2 cos 60. So it is positive. Just 1 minute.
आपण बजेटसाठी
200 into 2 cos 60. Okay. Then this force 600. Then again see 200 into 2 cos 60. So now this force is moving downward. Point is at this position. So if you rotate this force about the point, you will get the direction. If you rotate this force about the point, it is in the clockwise direction. So this is positive. Again, in the case of 600, if you rotate this about the point, this point, then it is again clockwise, means positive. So plus, again it is 600 into, now see what is the distance. So this distance is 3 meter. This much is 3 meter. Now this is vertical force. So this is the horizontal distance. This is the horizontal distance. So if this is 3 meter and this is 60, then this will become 3 cos 60. This distance will be 3 cos 60. I hope you all of you are cleared with the trigonometry. Maths मध्ये शिकताय तुम्ही trigonometry and sin cos all that. कारण सिंपल आहे. जर समजलं नसलं तर सांगा, परत मी ट्रायंगल घेऊन तुम्हाला सांगतो एक. हे समजतंय नाही कसं येणार ते 3 cos 60.
Yes, sir.
येस सर
ओके. ज्यांना समजत नाही त्यांना अजून एकदा सांगतो बघा. हा जर तुम्ही ट्रायंगल कन्सिडर केलात तर हा राईट अँगल ट्रायंगल आहे. सो दिस विल बिकम युअर हायपोटेनियस. आपल्याला ही साइड कॅल्क्युलेट करायची आहे. हा अँगल तुम्हाला माहिती आहे 60 डिग्री. सो ही ऍडजस्टंट साइड तुम्हाला पाहिजे. सो इफ यू यूज कॉस ऑफ थिटा, so cos of 60, then it will be adjacent side, let it be x. So cos of 60 is equal to x divided by 3 येईल. सो मग 3 ला जर तुम्ही त्या साईडला पाठवलात तर x is equal to 3 cos 60 होईल. जी काय व्हॅल्यू येईल ती येईल. ओके. सो आफ्टर दिस टू, नाव what is remaining? This RB. Now to calculate the RB, we should know this much of distance, because if you extend this line of action, this is the distance of RB. So now we need to calculate this. Okay. So this is 4. This is 4. And this is 60 degree. Then हे किती येईल? How much will be this distance? It is 4 sin 60. It will be 4 sin 60. So here I will write minus, because RB will rotate in anti-clockwise direction. See, RB is moving in this direction. So if you rotate this RB, it will rotate in anti-clockwise direction. RB will rotate in anti-clockwise. So it is minus RB into 4 sin 60. RB into 4 sin 60. 4 sin 60 जे काय आन्सर येईल ते येईल. ओके. बरोबर आहे ना 4 sin 60?
Yes, sir.
Okay. So now then this FB. So here see, I have, for our understanding, I have shown this force here, or I have shown FA here. Actually this frictional force are always acting on the surface itself. So FB should be here and this FA must be acting over here. In any thing, it may be the problem of block, it may be the problem of sphere, or anything else. It may be the problem of two blocks which is tied with the rope. What type of problem it may be, you should always remember that frictional force is always acting on the surface. So for our understanding, we have shown the forces like this here, Fa and Fb, but it is actually on this surface. Okay, so now here you can see Fb is acting over here. This is the line of action of Fb. If I extend this Fb, this is the line of action of Fb here. And our point is at this point. So this total distance will be the lever arm or perpendicular distance of this FB. And again, FB is moving up. So if you rotate the FB about the point A, then it will rotate in anti-clockwise direction. This will rotate in anti-clockwise direction. So it is minus FB into this distance will be, if this A to B distance is 4, then it will be 4 cos 60. It will be 4 cos 60. Okay, so nothing is remaining now. So equate this to 0. Equate this to 0. Okay, now solve this and let me know what equation you will get. Now solve this. What values you will get? Here 200 into 2 cos 60. So 200 into 2 cos 60 will be 200 as it is. So I will write here 200 plus, then here 600 into 3 cos 60. So 600
900.
into 3 cos 60, it is 900. Okay, so this is 900. Then RB into 4 sin 60. So 4 sin 60 चा calculation करा. किती येते 4 sin 60?
3.46.
3.46. Okay. So RB is plus or minus. It is minus and this is also minus. So I will send the RB to that side. So it will become plus. So it is equal to 3.46 into RB and also plus. I will send this FB into 4 cos 60 to that side. So 4 cos 60 म्हणजे किती येते सांगा?
5.46.
4 cos 60. It is 2, no? 4 cos 60. Cos 60 म्हणजे
Yes, sir.
cos 60.
So
Okay, so 4 cos 60 is 2. So it will become plus 2FB. So this is our equation. Now, from equation 2, FB is equal to what? FB is equal to 0.2 into RB. Okay, this is from equation 2. We have already written over here. FB is equal to 0.2 into RB. Now keep that value over here in this equation. So 900, 200, it is 1100 is equal to 3.46 RB plus 2 into 0.2 RB. So if you solve this, 0.46 RB plus, now do it, 2 into 0.2.
0.4.
0.4 RB. Now take RB common and do the addition and let me know the value of RB now. This is now simple calculation. Do it and let me know the answer. What is the answer RB? Correct. 3.46 plus 0.4.
284.9.
Okay, it is 284.9. Okay, Newton. So this is the value of RB. So this is what is the value of RB we have got right now. So once we know the RB, here we can find out FB from this relation. Here you can already see this relation is with us. So we can find out FB. So put the value of RB here and calculate the value of FB. So therefore FB is equal to 0.2 into 284.9. So what is the answer? Frictional force at B.
$56.98.
56.98.
56.98 Newton. Okay. So this is the value of FP. Now we have got these two values. Okay. Now we know what is the value of FB and we know what is the value of RB. Okay. Now we have to find out what is the value of FA, what is the value of RA, and what is P. That we need to find out. So now what we will do, we will apply summation Fy equal to 0. Now we will apply summation Fy equal to 0. So the upward forces are positive, downward forces are negative. So now see, we will apply summation Fy to hold this ladder. So now see how many vertical forces are there. Now this FB is moving upward, so it is plus. FB हा कसा असणार आहे plus. Okay, 600 is moving downward, so it is minus. 200 is also moving downward, so it is also minus. And then this RA is moving upward, so it is plus. So RA and FB are plus, and 200 and 600 are minus. So that I will write over here. So it is RA plus FB minus 200 minus 600 is equal to 0. But we know the value of FB. FB it is 56.98. So therefore RA is equal to, if we switch all the terms to that side, it will be 200, which will become plus, 600, which will also become plus, and FB will become minus, and minus 56.98. It is 56.98. Therefore RA is equal to, what is the answer?
$743.02.
743.02. This is the value of this RA. This is the value of RA. Okay. Now after RA, we can calculate FA also. Okay. So from equation 1. Okay. So we can write directly now. FA is equal to, what was our equation 1? FA equal to 0.3 RA. Okay. So FA is equal to 0.3 into RA is 743.02. Therefore FA is equal to, काय आहे answer?
$222.90.
222.90.
222.90. Okay. So it is 222.90 Newton. So this is the value of FA. And now finally we will calculate the value of this force P. Okay. Now what we will do, we will apply summation Fx equal to 0. Now apply summation Fx equal to 0. So the clockwise forces, sorry, if the force is moving towards right, it is positive. If the force is moving towards left, it is negative. Summation Fx 0. Now go to the diagram, see how many horizontal forces are there. See this RB. RB is horizontal and it is moving towards left. So RB will be minus. RB will be minus. Then this P, we have assumed this P is moving towards right. So we will take it as a plus. Our assumption it is. Obviously, if we get the negative answer, then we should change the direction of P. So now we have assumed that P is towards rightward direction. So P, and then FA is also in the right hand side, rightward direction. So FA and P are plus, and this RB will be minus. So here FA plus P minus RB is equal to 0. So FA is 222.90 plus P as it is minus, what was the value of RB? RB is 284.9. RB is 284.9, which is equal to 0. Therefore, P is equal to minus will become plus 284.9 and this will become minus 222.90. So if you solve this, you will get the value of this P.
62.
62.
62.
Okay, 62 Newton. Okay. So the force of 60, what is the meaning of this? The force of 62 Newton should be applied from here. म्हणजे इथं ज्याला कोणी तुम्ही शिडी धरायला उभं करताल त्या माणसाने किंवा त्या व्यक्तीने जर 62 न्यूटन एवढा फोर्स जर अप्लाय केला तर ही लॅडर स्लिप होणार नाही. जर फोर्स हा 62 न्यूटन पेक्षा कमी असेल then this ladder will slip. Okay, then this ladder will slip. This is the meaning. This is the meaning. नुसतं प्रॉब्लेम सॉल्व्ह करून त्याचा अर्थ पण समजायला पाहिजे काय आपण ऍक्च्युअली कॅल्क्युलेट केलंय. तर आपण काय कॅल्क्युलेट केलंय की when a person is climbed on a ladder, okay, and it is at this position at a 3 meter from point A, his weight is 600 Newton, then if the force of 62 Newton is applied at point A, okay, by any means, or by another person, if he apply or she apply a force of 62 Newton on the ladder, then that ladder will not slip. Otherwise, if the force is less than 62 Newton, then it will definitely slip. Okay, so this is the concept of ladder friction. Now we have solved this numerical. It is in front of you. If any problem is there, you can ask me. It may be small problem or big problem, you can ask. That is the small things such as that 2 cos 60, 3 cos 60 हे कसं आलं, 4 sin 60 कसं आलं, कळलं नसलं ते पण विचारा. दुसरा कुठला पॉइंट जर कळला नसला तर विचारा. आय विल गिव्ह यू 5 to 10 seconds. काय डिफिकल्टी असली पटकन विचारा. अदरवाइज वी विल मूव्ह टू द नेक्स्ट प्रॉब्लेम. Anybody is having any doubt in this, whatever numerical we have solved? Yes, no?
No, sir.
Okay. Then shall we move to the next numerical if you understood this?
Yes, sir.
Okay. Okay, good. So now we will move to the next problem. A ladder is placed बर ह्याच्यामध्ये आत्ताचा जे प्रॉब्लेम घेतला ह्याच्यात तुम्हाला एक गोष्ट सांगायची राहिली. ह्याच्यामध्ये तुम्हाला कधी कधी रिव्हर्स सुद्धा देतात बरं का. कधी कधी तुम्हाला काय केलेलं असतं, पी ची व्हॅल्यू दिलेली असती. Suppose a force of 60 Newton is applied at point A, which prevents the ladder from sliding down असं सांगितलेलं असतं. आणि ह्या जे 60 डिग्री अँगल दिलाय की नाही, हे अँगल तुम्हाला थिटा म्हणून अननोन म्हणून सांगितलेला असतो. This theta is unknown. So in that case also you have to go by the same method. Instead of this you have to keep the value as theta, and then you have to solve the equation. Okay, this type of problem may be asked. Okay, up till now it is not asked, but it can be asked. No, anything extra will be given to you. Instead of finding out this P, they will give you the value of P. Okay, and they will ask you to find out theta. This type of problem also may be there. If we found such a problem, then also we will take. Okay, so a ladder is placed against a vertical wall as shown in figure. As shown in figure. Full stop. A man weighing 800 Newton reaches at a distance of 2.7 meter from A. From A. A ladder is about to slip. A ladder due to which a ladder is about to slip. Okay, full stop. Assume that the coefficient of friction between ladder and the wall is 0.2. Determine the coefficient of friction between ladder and floor. So this is the numerical. Ladder is placed against a vertical wall. I will draw the diagram in the next lecture. Okay, now the time is over. So a man is weighing 800 Newton, reaches at a distance of 2.7 meter from point A. A point is at the bottom, due to which a ladder is about to slip. Now the ladder is about to slip. Now it will slip now. Okay. So assume that the coefficient of friction between ladder and wall is 0.2. Now they ask you to determine the coefficient of friction between ladder and floor. Okay. So in the next lecture, we will solve this numerical. In the next lecture, we will solve this. Now give me the attendance. Just a moment. Okay. Rule number 1,
Present.
2, 3.
Present, sir.
Rule number 3,
Present, sir.
4,
Present, sir.
5,
Present, sir.
6,
Present.
7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11, 12,
Present, sir.
13, 14,
Present, sir.
15,
Present, sir.
16,
Present.
17,
Present, sir.
18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24, 25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29, 30,
Present, sir.
31,
Present, sir.
32, 33,
Yes, sir.
34, 35,
Sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39, 40,
Present.
41,
Present.
42, 43,
Present, sir.
Present, sir. 42.
okay, 44, 45,
Present, sir.
46,
Present, sir.
47, 48,
Present.
49,
Present.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56, 57,
Yes, sir.
58, 59,
Present, sir.
60,
Present.
61.
Present, sir.
Okay, now I will once again announce the absent number. If anybody is present, let me know. So roll number 13, 13, 18, 29, 32, 47, 56. Okay, so today we will stop over here. We will meet in the next lecture.